Hi students, in this video we are going to discuss about a Cbse numerical. It's a book back exercise numerical from alternating currents. I have given the problem here. It's problem number 7.11. Let me read the problem for you. In the figure, a series LCR circuit connected to a variable frequency of 230 volt and inductance value is given, which is 5 Henry, and capacitance is given 80 microfarad, and resistance is given 40 ohm. So they have asked three things. First, determine the source frequency which drives the circuit in resonance. See, basically, students, this LCR problem, LCR in series. So based on this, there is a high possibility in a Cbse board exam they might ask one numerical. So it's basically an easy numerical only. It's not a tough one, though the problem looks bigger, but it's actually very easy. See, let me do one by one. See, first thing they have asked the source frequency which drives the circuit in resonance. So meaning they are asking the resonance frequency. See, generally in Cbse they don't give the word directly, but here the source frequency which drives in resonance means it's resonance frequency. It's quite simple. See, we know the formula for resonance frequency omega naught, which is equal to 1 by root LC, and let me substitute. So 1 by root over, and L we know which is 5 Henry, and C we know it's 80 microfarad. So 80 into 10 power minus 6. Okay, and very next step I can take 10 power minus 6 to the numerator, and we have to take root, so 10 power 3 and 580 is of 400. It's very simple. So 1000 by root 400 is 20, and then the answer is 50 radian per second. So this is omega naught. So you can, if you want, you can find f naught also. If you want to find f naught, you have to write the formula 1 by 2 pi root over LC, but okay, it's enough. If you find omega naught, it's okay. So this is the first subdivision A, and we have found the answer. And see, coming to second subdivision, they are asking obtain the impedance of the circuit and the amplitude of the current. They are asking two things basically. They are asking impedance and amplitude of current at the resonating frequency. So it's again quite simple because they are asking at resonating frequency only. See students, at resonating frequency impedance is Z, but we know at resonating frequency, you all know very well, Z is equal to R. And they're asking the amplitude of the current also. So at resonating frequency, I will be I max. So we want to find basically, so no need to find Z. R value is already given. It is given in the input, which is 40 ohm. So that will be the Z at resonating frequency. So I max. So if you want to find I max, so I max or I naught is equal to V naught by Z. So at resonating frequency, V naught by, if you want, you can change V naught by R also, because Z is equal to R, and V naught is, we know, VRMS into root 2 by R, because in the input given is VRMS, which is 230 volt into root 2 by resistance is 40. So if you simplify, you will get the answer 8.13 ampere. So this is basically the peak current, the maximum current, because we know very well at resonating frequency current will attain peak. You know, you would have seen this graph also. If you want for reference, you can use this graph. So current attains maximum I max at that resonance frequency. So you can recall this graph. So we found the impedance and maximum current at resonating frequency. Okay, now coming to the last subdivision. So determine the RMS potential drop across the three elements. So individually across all the three elements, we want to find the, that is, potential drop. So VL, VC and VR. See here we want to find the RMS potential drop, so we have to take IRMS. So generally students will do common mistake here because they found the peak current value already, so they might use that peak value. So you have to change I naught by root 2, it's an important thing. And similarly instead of XL you can write L omega naught. So now it's a direct substitution. You can go for the direct 8.13 which we already found into L value is known, which is 5 Henry, and omega naught is also already found, which is 50 radian per second. Just it's just a substitution, so you'll get the answer. So if you calculate, the answer for voltage across inductor will be 1437.5 volt. And here for this IRMS current, if you want you can even go for IRMS is equal to Vrms by ZR R. So in this case Z is equal to R. So Vrms we know which is 230, and R value you know which is 40. So you can use this method also. You can use this IRMS also if you don't want to go for 8.13 by root 2. So whichever is convenient to you, you can use. So similarly, we want to find voltage across capacitor also. So IRMS into XC. So this time now I have used the other method. Instead of IRMS, I substituted 230 by 40. So both it will be same. And XC, you know very well, it is 1 by C omega naught. And just substituting the values again. See, interesting, you will get the same answer because it's a resonance circuit problem. And you know very well, for resonance circuit XL value is equal to XC. So in both the cases you will be getting the same answer, so 1437.5. And if you want to find VR, again IRMS into R, so you will again get the same voltage, input voltage, which is 230 volt. So basically in all resonant circuits means XL and XC, they will be present but their values will be equal, so they nullify each other. When you go for Z, you know root over R squared plus XL minus XC. When you go for XL minus XC, they nullify each other, that's why Z becomes R. So that is the answer for the last question, that is voltage across LC combination. We want to say it is 0. Yes, of course, we know XL is equal to XC. So when I go for XL minus XC, this term becomes 0. So anything multiplied by 0. So it is, so voltage across the LC combination will be 0 volt. So yes students, it's an important problem and a easy one also. If you know the methodology well, you can answer easily. So hope you understood this problem. I've given again written the answers, everything in the question itself. So any doubts you can post in the comment section, and if you have not subscribed our channel, I ask you to subscribe also. Thank you very much, all the best.